A very good morning to one and all. I'm Professor Nidhi from SIIT. Today we are going to start our fifth topic, classification of fluid flow part 2, where we are going to study compressible and incompressible flow. The compressible and incompressible flow depends upon the level of the variation of density during flow. That is, incompressibility is an approximation. As we know that incompressibility is an approximation and flow is said to be incompressible if the density remains nearly constant throughout the flow. Therefore, the volume of every portion of the fluid remains unchanged over the whole motion when it flows. This is what it is incompressible. The densities of the liquid are essentially constant, and thus the flow of liquids is typically incompressible. Liquids are usually referred to as incompressible substances only. Moving towards more points, a pressure of 210 atm, for example, the cause of density of liquid water at 1 atmospheric temperature to change by just 1%. Gases, on other hand, are highly compressible. Their pressure changes at just 0.01 atm. The flow of gases can often be approximated as incompressible if the density changes under for about 5%. The compressibility effects of air can be neglected at high speeds under about 100 meter per second. So this is a particular difference between compressible and incompressible flow. Moving towards the laminar versus turbulent flow, some flows are very smooth and others are not very chaotic. The highly ordered fluid motion characterized by smooth layers. A flow with a very smooth appearance is known as laminar flow. The flow of high viscosity fluids such as oil at low velocities is typically an example of laminar flow. The highly disordered fluid motion that may typically occur at high velocities and is characterized by velocity fluctuations, which is known as turbulent flow. It means that a flow which is not smooth or with full fluctuations is called as turbulent flow. This is the basic difference between laminar, transitional and turbulent flow. The flow of low viscosity fluids such as air at high velocities is typically turbulent. And a flow that alternates between being laminar and turbulent is called transitional. That means it may be a mixture of smooth and turbulence with some mismanagement of visible layers. So this is how we are explaining the laminar and turbulent flow. Now moving towards the natural or forced flow. The flow is said to be natural or forced depending on how fluid motion is initiated. In forced flow, the fluid is forced to flow over a surface or in a pipe by external means such as pump or a fan. But in natural flow, there is no external means such as pump or fan. This flow is due to the buoyancy effect, which manifests itself as the rise of warmer fluid and the fall of cooler fluid. In solar hot water system, for example, thermosiphoning effect is commonly used to replace pumps by placing the water tank sufficiently above the solar collectors. So it is quite clear the difference between the natural and forced flow. Now we are going for the steady versus unsteady flow. The term steady and uniform are used frequently in our engineering. So this is quite important to have a clear understanding of their meanings. The term steady says no change at a point with time. And the opposite of steady is unsteady, which implies no change with location over a specified region. So I hope it is quite clear to all of you that steady versus unsteady flow says that no change at point with time says steady, and no change with location over a specified region is unsteady. Thank you for the 5th lecture. We'll continue in our next lecture. Have a good day.